All right, Alex, we are gonna do this walkthrough of one of the old assignments I had for my data management class, where half of it was in SQL and the other half was in R. But you probably care about R more because both of us will probably use it in the future at some point for some jobs in like marketing or campaigning or some other analytics like bullshit. So for this first assignment, I'll probably just post a link to my redacted copy of the information just so it has like only the relevant information that you need and not the other both like stuff. But in this first assignment, we're looking at some vehicle fuel efficiency and emissions testing data that the EPA did in Ann Arbor. Fuck Michigan, by the way. So we're gonna first import the data and just straight up copy and paste this code. So this is going to be like reading in the data, and then this will be changing some of the data types for the variables in the data set just to get started. So first you're going to want to pull up RStudio. You can run R by itself, but it's not as pretty looking and it doesn't have like the like global environment and all this other stuff. Like if you just ran R like by itself, it would basically just be the console. I can pull it up here somewhere. Yeah, like if you just pull up R by itself, it's just the R console, and that's kind of a pain in the ass to work with. So we pretty much do everything in RStudio because you have the console down at the bottom left, and then you can do all your editing your script or whatever up in the upper left. And then over here on the upper right is like your environment tab. So when we go ahead and read in the data, so I copy and pasted, and then when you're hovering over the script or the line that you want to run, you can just hit Control Enter or Command Enter. Okay, so it didn't run, and I get the message down here that it could not find the function read CSV, and that's because I didn't load my library. And the library that I want to load is the tidyverse library. So the way R works is that you basically just load packages that you need to use. And once you have installed those packages on your computer, you just, when you call up, like start up a new environment or whatever, you just call up the library. And in this case, the library tidyverse actually has several libraries in it, like ggplot, tibble, tidyr, readr, and all that other stuff. If you refer to the R for Data Science book, written by Hadley Wickham and his buddy, they just kind of explain all of that because Hadley Wickham actually developed all the packages in tidyverse, and that's like his big contribution to the R community. So like among the nerds, he's like the god of nerds for data science. So now that we've loaded the package that we need, we can read in the file. So the way this evaluates is that it'll read everything on the right first, and then I'll go to the left. So what we do here is we are creating a data set called vehicles, and this data set will come from this information right here. So like this CSV file, and CSV stands for comma separated values or something. And for the data types, my professor was very nice and just made a string of threads just for the data types for the read CSV function to read in. So like the first column is going to be let's see. So the first column will be like an integer, and then like a number, integer, number, C for character, I for integer, CCC for the next three columns would be characters, then integer, character, integer. Oh. And then next, he has these 4 lines. So you just go ahead and copy and paste these in. So what this will do is, this will make the column for vehicles. So currently, vehicles is, scroll over. Okay, so the data's vehicles, currently the class column, right? Those are characters, and you can see it over here in the upper right. So those are all characters, and we want to make these something more meaningful, because a character is basically just a sequence of letters, so like a string, and we can't really do much with that. So what he does instead here is he's going to turn that into a factor. So that's like kind of like types of Pokemon, right? Like it's not a number, but it's like a factor. So rock is different from like water and fire and whatnot. And then we're also going to do the same thing with the drives, because currently drives is a character string. We can't do much with that, so we're going to make it a factor. The same with make. We're going to make that a factor. And then transmission type, automatic, manual. Just having a string of characters doesn't mean anything. So we need to make that a factor, because later on it's going to help us with some of the visualizations that we want to do. And then here, so these are what the variables stand for. So city MPG is city miles per gallon. You have some your CO2 emissions, cylinders, displacement, drive axle type, highway MPG, make, model, class, year, transmission speed, just the usual stuff. Okay, so the first part we're gonna do 5 graphs with from the data, and then so for the plots you're gonna use a lot of the ggplot2. So I want to make a scatter plot showing the miles per gallon for city driving on the y-axis, in the emissions. Okay, MPG on X and CO2 on the Y. So now, if you're like me and you forget your shit, you pull up because you're trying to plot things, right? So you're gonna pull up the ggplot2 cheat sheet. So this kind of tells you just how to, examples of all the things you can do with the visualizations. And then the way it works is you start with one of these, and then you'll like hit do plus, then just add more continuous layers. So what I'm going to do is call up the ggplot, and I want to use the vehicles data set. So I'm going to use vehicles because that's the first argument. And then I'm going to want to do a plus because I want to add a layer to it. And because I want to add a scatter plot, I go to these cheat sheet, right? So we have 2 continuous variables. So miles per gallon and emissions, they're both on a continuous scale that can go, in theory, from 0 to infinity. And there's no like set interval. So we can go ahead and just use one of these functions here in this list. And the one that makes the most sense for us is going to be this geom point, because it just does like a scatter plot. So we're gonna go ahead and add, not that one, point. Then you have to do this syntax here. So for the ggplot argument, you're gonna need to have, so your data set, so we did that up here in vehicles. So now when we do the geom point, we need to add what we want our x to be and what we want our y to be. So now we do mapping, aesthetic, and then x equals, oh my goodness, what do we want it? City mpg, then comma, we want our y to be CO2 emissions. I think I did this right. Once you have your code, you just do anywhere in the sequence and then control enter. And then here's our plot, right? So you have city miles per gallon on the bottom and CO2 emissions on your Y. And as you can see, it looks like as your city miles per gallon increases, the lower your CO2 emissions are. So we're gonna, so to do a comment here, you do a pound sign. So anything after the pound sign in this line 12, even if I try to run it as code, it will not run because that's just how comments work. So this is problem 1, part A. Ooh, okay, so we're gonna have problem 1, part B. And in part B, we want to create another scatter plot with the same information, but we use color to distinguish the vehicles by the drive type. So we're going to copy this because we still want the scatter plot, but what we want to do is add another layer to it. So if you look at the cheat sheet on the geom point function, there's also a fill, shape, and size like arguments you can add. And we did not do that at all in part 1. So these are just parts, like more things we can add to our visualization that we haven't done yet. And what we want to do is we want to use color to distinguish the drive type. So one thing you can do if you're not sure is you can hit F1 when the cursor is like on the function. And you can see the examples of arguments here. And I think what I want to do, I think I want to do color equals drive. So what I want it to do is I want to plot the city miles per gallon on the x-axis and the emissions on the y, like I did earlier. But for color, I wanted to differentiate things by the drive type. So I added another argument, color equals drive. And so what this means is because earlier we were very smart and just nabbed the professor's code, and he made the drive type a factor. So what this does is it gives the characteristic. So my my example earlier was like the Pokemon, like you have rock type, water type, whatever, and you all know like rock is rock, water is water, right? But for the program, when it read it in this data for drive types, like a two-wheel drive didn't necessarily mean two-wheel drive to the data set and to the program. It just meant that two-wheel drive was just a 7, 8, 13 like length character string, and it didn't have any really any value for us besides being a string of like character spaces and all that, whatnot. But when we made it, converted it to a factor earlier with the as factor in this line, in line 8, we could actually use it later down the road for this visualization. So down here in line 19, when we had it, we set the color equal to drive because drive was a factor that differentiated the colors. So we zoom in, and you can see here that the color is the graphic is a lot more colorful because it also includes this element by showing the factors. And that's what we had to do for problem 1, part B. So now for part C, we need to create a stacked bar chart that shows the number of vehicles tested broken out each year, broken out by vehicle class. So for this one, we're going to have to use a different approach and also understand that things are going to be a little bit different. So for part C, I'm going to do something different. So instead of like right here, where I use ggplot, right? And the first argument is data. So that's like where you get your data from. And I said I want to call it from the vehicle spreadsheet. What I'm going to do is use vehicles here and then use a pipe. So this percent greater than percent together, think of it as like when you're reading the code, it just means like then, right? So you can use it to do like multiple functions on your data set or like a line, like in a sequence. And I remember during this class, we used the word pipe. Like my professor said pipe probably no less than 600 times. And he just said pipe something, pipe something, pipe something. I'm like, shit, dog. Like I ain't piping anything right now. Fuck. But that's beyond the point. So we're going to do a plot. So we call the ggplot function. And because we have this pipe right here, so it's just moving it down to this ggplot function. So essentially, this code right here, the ggplot, then vehicles in the parentheses, it is the same as, that's not what I wanted. This vehicles pipe and then ggplot. So that's like the same thing. So this will pass the vehicles argument into here. I'm pretty sure I could have explained that in a less painful way, but that's the best I have right now. So because we've already piped the vehicles into ggplot, we just do the graphics part. So mapping aesthetic here. So you have to do that. And what we want to do is show the number of vehicles tested each year broken out by vehicle class. So on our x-axis, we're going to separate things by year, because that's what we're looking at. And then what we want to do is, actually I fucked up. So what we want to do is call the ggplot function, then add a layer, and we want to do bar charts, right? So like in the problem above, I called the ggplot function, and then I added the points, to do the scatter plot. So that's the layer I added. And here I want to add the function for bar charts. So if you look at the nice little cheat sheet here, we have bars. So bars will have one discrete variable, and that's exactly what we need. So you just need an x-axis and then whatever. So on the x-axis, we have the year. And then after that, we want to... So geom bar has color and fill, right? And there's a difference, because so this is what the bar chart looks like when we just run it without any colors. And what happens is when you do color equals, let's just do blue. Okay, that's totally not blue. Yeah, I fucked up the color. So what color's gonna do is, okay, assume I didn't fuck up the colors because I never use colors. What it would do is it would change the color of like the whole bar itself, which wouldn't help us at all because we want to do a stacked bar chart. So we want to find out what the difference is in like the fill of the bars. So what we're gonna do is add an argument for fill, and in the assignment we wanted to do that shows it by vehicle class. So in the bar charts, we're going to do a stacked bar charts to just have more representation of the different types of classes. And because we made class a string from a string of characters to a factor earlier, we can just pass this in. So now we get this very rainbowy color. So what we did was we used the bar chart because we had like one variable that was discrete. That was by year. And what we do is then we had the fill. So for each bar, in each bar, we added the layer of color, and the amount of color represents the different classes of cars. I'm not quite sure how useful this is, to be honest. I don't find it useful at all, but this was what the assignment wanted, so we just roll with it. Just do part D. So in part D, we wanted to create a set of histograms that shows the number of vehicles tested by mileage per gallon during city driving. And we need to use one call to ggplot that creates separate histograms for each transmission types. And then my professor straight up pointed out right here that we didn't do histograms in class, so we have to do some extra shit on our own. And a hint, simplify things, create a single histogram first, and then add commands that break it into different histograms for each transmission type. Ooh, and this is the part that a lot of people got stuck on for a while, but for me, I was staring at the cheat sheet for a while, so I found something that I might want to try out, and then I did the guess and check. But because I've done this already, I'm just trying to walk you through things as, like, after you've done it yourself, this shouldn't be a problem. So what we're going to do is we're going to call vehicles, add a pipe. Oh, fuck, I hit save. I don't want to save it. So what I'm going to do is pipe the vehicles data set into ggplot. And ggplot stands for like grammar of graphics planning. What the fuck did I just do? Yeah, okay. Anyway, so we're going to add a plus sign because we want to add a layer. And we want to add histograms because he explicitly said we needed histograms. Right? think that makes some sense. So we're going to do plus geohistogram. And let's look at some of the arguments for histogram. So you have x, y, bin width. Let's just go ahead and set the bin width to like 1, because we're just trying to show like vehicles by mileage per gallon. So what this is going to do is if we put miles per gallon on the x-axis, we just have it set up by bins of 1. And then now we're going to do mapping equals aesthetic, because that's what we care about, you know. Gotta flex that back. And on the x-axis, we have city miles per gallon, because that's what he said we straight up needed. And then we also want to show the number of vehicles tested. By transmission type. So what we're going to do is we're going to fill by transmission type, because that's what we want to explore in this graphic. So when we run this, we run that line of code right there where we do histograms with bin size of 1, and on the x-axis is miles per gallon, and then the fill type shows the transmission. We get it all in one plot, which isn't super helpful at all. But on the cheat sheet, it kind of just gives you a quick rundown of everything. So the first time I did this, I didn't look at faceting, right? And faceting was a very interesting function to examine. So what this does is facets divide the plots into subplots based on values of one or more discrete variables. And luckily for us, we are dealing with discrete variables. So these will 100% apply. And what we want to do is separate our data out by a transmission type. And as you know earlier, we made transmission type a factor, so that works. So we're going to go ahead and hit plus on our existing code here to add another layer. We're going to do facet grid. And we're going to use grid because over here it'll break things into columns based on whatever FL is, whatever your argument is. So over here, we're going to do period squiggly. I'm not sure what it's called, but fuck it. And then this FL is going to be what you want to try to break the column, break up the columns into, right? And we already said earlier we want to do it to transmission type. So we run it, and now you have the breakdown of city miles per gallon on the x-axis, the number in each year, or the number that hit that mark, and then divided by transmission type. I'm going to do part E. So this is actually the part, like, on the real homework assignment. Like, I skipped it because it was at the top of a page and it was easy to miss. Actually, it might not have been. Ooh, I'm really good at screwing these up. Alright, let me take a quick look at something. I know there's a part E somewhere that I missed. Oh, just kidding. It was a part D. It was this one. But we're not there yet. So we don't have to worry about it. Okay. So we've finished all of problem 1. Now we work with problem 2. Problem 2, part A. The real question is, do I get a vape? Right? What do you think? You can tell me later, Alex. Okay. So what we want to do in part 2 is to print a table showing the minimum, max, mean, median city miles per gallon for vehicles tested, broken out by vehicle class. We want everything to be displayed as an integer, and then we might need to round things. So he's telling us that we need to use as integer and to round things. So in R, right? Or actually any program, you have like multiple different types of data. Like we talked about strings earlier and characters, the character strings or factors. So integer is what it sounds like. It's just an integer. And then you have the data type like double, where it will also do decimal points too. But one of the nuances of integer is that if you have a number like 23.7, like in your mind, when you have to round it to the nearest integer, right? It goes up to 24. But in R, or I think a lot of programming languages, if you try to make 23.7 into an integer, it'll actually just become 23 because it truncates it. So anything after like the integer part of it, it just drops. So it doesn't round. So what we need to do here uh, is we're gonna have to round if necessary, and then use as integer at the end to print out the table that we want. So in this data set, we're not using visualization for this part. So now luckily for us, there's another cheat sheet, and we're using dplyr. So with dplyr, this is the package that Hadley Wickham designed for part of his tidyverse library with all those other packages. And the idea behind this is to help you tidy up your data uh, with each variable having its own column and then each observation as its own row. And this honestly took me a little while to like wrap my head around, and it didn't really get easier until I spent more time playing around in R and trying to get used to it, and then also doing some more reading. And then you can probably find a couple classes on like Udemy um, that I linked you earlier that you can just run through that should help explain things if you need more explanation, and that's fine. But so some of my friends will just like look at this and just try to like plug and chug away at the programming, and what happens is because they try to take a shortcut, they actually spent more time on the homework assignments than I did because I would spend a lot more time on the front end trying to wrap my head around the concepts of how things work instead of, you know, guessing and checking until something worked, which is easy to do in a script-based language. But it's definitely worth taking some time at the beginning to just understand like the ideas and philosophy, so to speak, of what he's trying to do. So what we want to do in part A is to pull out all this data from the vehicles, right? So we're going to call the vehicles dataset, pipe it. So essentially, in English terms, that just means then what? And then what we want to do is we want to group it by something. So I pulled up the group by function and then hit F1 to get the help tips and how it works. And it just tells you the arguments for group by. You have the data, which we've already passed through with the vehicles, and then pipe, then add, and then X, and like what do you do with that, right? X is like what do you want to group it by? And here I want to group it by class because it explicitly says broken out by class. It's pretty straightforward. Pipe it to our next argument, and what do we want to do? We want to find the minimum, maximum, mean, and median data for all of this. So what we're going to do is summarize because it's an aggregate function. So you're going to use reduces multiple values down to a single value. So if we just run this code right now by itself, so down in the console we see that it just spits out a list of the different types of classes we have because we took our vehicles data set and then grouped it by class. And then we summarized it just to see a summary of it. And we just see all 10 classes of vehicles that we have. But that doesn't help us because we want to find the minimum, maximum, medium, and median, right? Just some of these descriptive stats that you see. So what I'm going to do is use the min function. And what the minimum function does is returns the maximum minimum of the input values. So we're going to input here is the city miles per gallon because that's the what we're trying to analyze just up here. What happens when you do that? So what happens is down here you get a tibble or just a little data frame where you have the class broken out. So it looks like the minimum miles per gallon for a compact car is 7. And then because we summarized it and decided to also look at this min CP city MPG, it spits out that column that says min parentheses city MPG, which is kind of ugly. So what I'm going to do is do an equal sign. So in R, an equal sign and also this little arrow, they mean the same thing because you evaluate everything on the right of it and then it goes to the left. I want to go ahead and call this min MPG. So that's one thing we also want to look at. Next we want to look at maximum. Actually, we also have to do the as integer function here. So down here in our console tibble, right, the data set for this was actually double. And that's not what we wanted. We're going to make everything an integer. So when we run it a second time, now we have renamed this column min mpg and it returns as an integer, which is what we want. And then the next part is finding the maximum. So we're going to do very similar thing. So max mpg is an equal so we're going to find max of city mpg, and then we also want to make it an integer, so we're just going to do as integer and then add another close parentheses here, and then we're just going to check our work so far. So now in addition to having the minimum mpg, we also have the maximum mpg for each class in the form of an integer, and so far we're getting what we want. We have the correct data type and then just the numbers. Next, the step we want to do is the mean, and I think this is where the rounding is gonna matter more. So we're gonna do the mean. There's the mean function, surprise, and what we want to do is do the mean of city MPG. We look at it like this. So I just ran the mean of city MPG. And what happens is we get this double, right? So we have the decimal places too. And we don't want the decimal places because we want to round everything to the nearest integer. So what we're gonna do is use the round function, like we talked about earlier. Yeah, use round if necessary. And as you can see here, it just rounded everything. I did mention earlier that if you just don't round it and just try to make it the integer type that you wanted, the rounding would be off. Right now, I'll just add another column here just to show that. So see here how, so in this column, this third column, we took the mean of the city MPG and just made it an integer instead of a double. And in this last column, we rounded that number. And there are discrepancies because of how it works. So like in minivan, instead of rounding up, it just truncates at 16 point whatever it was, you know. And it happens here as well. And then also down here. So that's why instead of just using as integer and trying to make it round like that, you actually have to manually round. So you take the mean, and then you round the mean, and then you want to make it as an integer. So the order of evaluation for the code is, I guess in a sense, parts of it are similar, like the order of operations. So like with all the parentheses and grouping, you do like inside first, and then you work your way out. So in this case, you start on the inside and work your way out. So now we have the mean MPG. And the last stat we wanted was the median. And what you can do is call the median function and then pass through the city MPG. And then just, because you know, like if you have an odd number of observations, or an even number of observations, it's possible that your median can be a decimal point, and we don't want decimal points. So to take care of that, we're going to use round again on the median. And then we're also going to, after we round it, we're going to turn it, make it become an integer. And now we're just going to name it. So the only the differences between what we did earlier and what we just did now is that we made sure we rounded everything nicely and then made it an integer, and that's how you do part A for that problem. It's kind of a bitch. So now I do part B. Display a line graph showing the change in average city and highway miles per gallon over time. We don't want to round integers this time, and we want to show city miles per gallon as red and highway as blue. So the important thing here is that we want to see some change over time. So time will be on our x-axis. So what we're going to do is we want to do like two different lines on the same plot, and both of the lines will show a different set of data. But the important thing is to remember that your x-axis is still going to be time. So we call our vehicles data set, pipe it. So then what? So we want to summarize the data, and we're looking at the average miles per gallon for city versus average for highway. So what we're going to want to do is create a new variable for city, and this city column is going to be the mean of the city miles per gallon. So if we test it once, we see, so I hit Control L to clear the console. So we can see that the mean miles per gallon is 17.5 for the city vehicles. But that doesn't help us necessarily. So now we also want to add the highway miles per gallon. So more or less we're going to do the highway miles per gallon. So when we're doing this, it's showing the means for the like whole data set regardless of vehicle type and whatnot, right? But we wanted, so we're building on to like building on what we want to get. We want to separate these into time, so we're going to pull up the plot because that's what we want to do. And we have, let's see, we want to use a line. Mainly because he explicitly said use a line graph, right? Directions are difficult. So we're going to pipe this to the ggplot. And what we want to do is add an aesthetic. Make it the year. So that's like so that was like shorthand version of doing what we did up here, where we did mapping equals aesthetic of x equals whatever. And here I just straight up said aesthetic. And then just by having year first, we're just saying like x equals. I can just throw that in. I think it should be fine. And then what I want to do is do a line. So I'm going to do geom line. And what are the arguments? So we need to have, we already have our x, which we said is year. And now we're going to add y equals, let's call it, we're going to use highway. I think that makes sense. So let's just plot this one variable and see what it looks like. And I fucked this up somewhere. Okay, let's see. Object highway not found. Maybe we need to do aesthetic equals parentheses. Okay, I guess that worked. So I also need to make the aesthetic y. I messed something up and I don't know why. Okay, I want to copy the answer I did earlier and see if this runs. Okay, so this one runs for whatever reason. I think I know why. Yeah, close this parentheses. Huh. Weird. Oh yeah, I just straight gave you the answer that I had. used. Like right here, I'm not sure why I can't find the year. Because that's what I use the whole time, right? So I'm not quite sure why it does that. And honestly, R does a lot of weird shit. Because you look at it, I have the year in parentheses here. So year, parentheses, parentheses, year, yeah. So this code won't run. But this code does. So I think... Honestly, I don't know. But I'm just gonna call it a day after part B. And then you can probably work on the rest and then we can just talk about it later. But this is my answer. And somehow I am unable to recreate my own answer. But what I don't understand is that it works up here, but not down here. I mean, other way around. It works down here, but not up there. And that makes no sense at all. Because I was basically just adding the same code. Alright, aesthetic equals city. And then color red. It just keeps telling me year not found. But we have data for the year right here. And for some reason it works when I run like my old code I had from the original assignment. And from what I'm looking at, it's... Oh shit. That's what I didn't do. So at the very top, I did not group all the data set by year. So if I ignore the plotting part, so I'm going to take the vehicles, group it by year, and then summarize the city and highway MPG, we get a lot more data. What do you mean city MPG not found? City MPG. I forgot the pipe. And that's how we get the graph. So first we take vehicles, we group it by year, and then we summarize the average city and highway per year. So this is why it's important to check the tibbles if you're going to do a pipe it all the way down like I did here and failed for the longest time and couldn't figure out why. And what I messed up was I wanted to group it by all the information by year before I did all the other statistics on it, right? And then that's... So first I take the vehicle data set, then I group everything the year. So here everything is grouped by year. But then I want to summarize all the data and take away these data points. So that's how we get the year, city, and then highway. And then after that I pipe it to the plotting function. And we get this plot. So there, that was me just messing things up by not having the due diligence and paying attention to everything. So don't do that. That's a big part of programming. Just figure out, like, make sure you follow your process properly and whatnot. So you go back to here. Part C, we want to modify the graph above to also show overall miles per gallon, and this overall miles per gallon is computed as the average of a city and highway. we can plot it as green. So what we're going to do is just go ahead and copy all this old data, but we also want to add a calculation for overall miles per gallon based on the average of city and highway. So what we're going to do here is do average. Average is going to equal city plus highway divided by 2. I think this should work. And it does. Because down here we can see that the average for overall is the average between city and highway. So that's what we want. So now we look at our chart, and our chart's gonna look exactly the same because we've added 2 lines to it, right? So what we want to do is add a 3rd line. So you do another plus geom line, then we do aesthetic, then we do our y, and we want our y to be the average. Then you gotta get out of the parentheses because we have y equals. Hit up that color argument. Let's do green. And now, as you can see, this is really fucking bright on that green. So the difference between this part B that we did is part B just had the highway and city. City is red, yep. And then this last part we did is we added another variable that showed the average between city and highway. And then we map that average. So that's why it makes sense, because on the zoomed in plot, it's pretty much directly between the two. So that was problem C. And now part D is we want to modify the graph we just did to show separate graphs for drive type. So let's just go ahead and copy this, right? Because we are using it the same as we did on these separate all the different stats, but now we want to separate it by drive type, and we did that earlier with the facets. So you pull up the cheat sheet and see that we can break out facets like this. But instead of doing facet grid, maybe we want to do like a facet wrap. So do facet wrap, and our argument is squiggly, and then indicate how we want to wrap it, or what's the factor that we're gonna separate things by. And we separate it by drive type. So then we just add drive. And what this should do is give us several graphs. Okay, maybe we don't want wrap. Maybe we want grid. Okay, let's try this. At least one layer must contain all variables used for faceting. Okay, let's think. So one thing you can do is basically just copy your error message and throw it into Google, because that's a good way of finding your problems or answers. So that's what I will do. Okay. Let's see what they do. Squiggly period. Period squiggly. So it works before I add the facets. And now it's not liking me when I use the facets. Oh, I just stretched my knees out and just popped. Whew. Oh, and then my back just popped too. Oh, that felt good. So we know we want it to wrap like we did up here. Facet grid. And then by whatever type. I'm gonna be honest, I'm totally blanked out on this one. I think we'll just have to test out all the facet wraps till one works. So it works when we don't add the facet. Then we do add the facet down here and it doesn't like it. Why not? 2 points. We have our 3 points. I'm gonna wrap it by drive. At least one layer must contain all variables used for faceting. Well, I will have to go look at my notes and try to figure that out. But pretty much walked you through that first assignment that I had. But yeah, if you have any questions about any specific part, just let me know and we can talk about it.